Hi there, and welcome to this new bonus lesson for Volume 3. We'll talk about mechanical rigging, and I have a simple scene here, and I really want to dissect it a little bit for you to understand what's going on before we start doing anything. Here I have a simple crane with some sort of mechanism on wheels, and of course this grabber hand, and these are all really simple objects, and you can see I have already set it up this hierarchy. So for example, when I rotate the arm, the rest will follow, and I left this to be on its own, so to speak, because here I actually have a cloner. If I uncheck this gizmo here, you will see that this is actually a single tooth or single piece, which is actually cloned 4 times on the object. And in this case, this object is this grab mechanism. And I cloned only on the point selection. So actually turn this off, you can see that point selection. So only to this 4 points. So we now have 4 guys here, which is really neat. Because the simple reason is it will be much more easier for me to animate it. Because here under transform tab of the cloner object, I can actually animate this bank value. I can really illustrate that grabbing motion on all 4 of them with a single control. Okay, so that is really useful, and you should really seek such solutions because they're easy to animate. So instead of 4 values, you have just 1 value to animate. So let's see what is the smartest thing to do here first. Well, first you have to know what you want to achieve. And in this case, I want these guys to really turn as a real wheels would. That's our first task, and mechanical rigging is not really that different than any other rigging. It's simply saying and instructing enough for the what to do and when to do it and what not to do. It's really simple. At least the principles are. In this case, we will help ourselves with the set driver command, but prior to that, I will freeze all values. So current rotation and position values will become 0, which is very useful for future espresso we might have. The expression that we need here is really simple. So moving this guy in Z should rotate these guys in rotation H. You can see it here. So let's give it a shot. Let's select the roller. We will right click on the Z value, and on animation we will select set driver, and we will select one of the wheels, and under rotation H we will right click and state set driven, and in this case we can go relative. You'll notice that we got an espresso tag here, so we can actually maybe dock this here because we will work with some espresso in this lesson, and actually center the nodes here so they're just right in the middle. And here we have some values which are probably not good by default, and we can check it out. So if we move this guy, this will happen. And if you really take a closer look, you will notice that this wheel is really rotating in a wrong direction. So it should be the other way around. So let's, here in the range mapper, let's reverse that and see what happens. And actually it seems good, but rotation is not quite what we should expect. You can see it's almost like the wheel is sliding, and we can actually rectify this with increasing this value. So let's try 200, for example, and see what happens. And this feels a lot more natural to me. Okay, so we can reset the position. You can see that is really useful. And we can actually do the completely same thing for our wheel number 2. So we will drop it here. We will find the rotation H value and simply connect this output. And if you want to be neat, you will do what I did, just to have some order in the scene, and actually I prefer espresso to be on the null objects, and I will transfer it here, and you can see that this guy became wheels. This is because of this relative reference mode, and we actually want to use absolute reference, and we will drop once again our wheel number 1 inside. We will test the whole thing, and it works really well. I will undo that, and we can continue. So now we have a part of our functionality. So for example, if I rotate this and maybe move this roller, I can always utilize the reset scripts that we made in the first few lessons and simply reset all that to 0. So we can even reset the roller, and you can see how these reset scripts are really useful in any type of rigging. So let's proceed to our next functionality we want, and there is a good reason why I use this cloner object instead of actual polygon objects. Not only because I want to utilize this rotation value here for opening and closing, that is because I also wanted to show you some ways you can work with cloner inside Express, and hopefully that will help you to grasp MoGraph a little bit better. But first thing first, you can see that I have my spline here, which will actually serve as some sort of a cable, and I want to attach this whole mechanism to this point. Okay, so you can see it's a little bit off now, but we can solve that. And to do this, I will actually add a constraint tag to my grab mechanism, and in clamp mode, I will select a point constraint and I will fix it to a target, and my target in this case will be a spline. And you can see the clamp is drawn here. And if you reduce this to 0, you'll actually have no distance. And by moving the point on the spline, you will move the complete setup. Okay, so let me undo that. And there is one more solution with which you can do that, and this is with the point node inside Espresso. And for the ones that are really not into Espresso, this clamp constraint in the point mode will going to work just fine. So let's say that we now have pretty much all the functionality we want from our crane. We can move it, we can rotate it, we can with this cloner object we can open and close this grabber, and there is actually one thing missing, and that is how to instruct these guys to pick up something. So let's say we create say maybe a cylinder and really scale it something like this, and pull it upwards. So try to find the size that will actually this grabber be able to encompass. So how to instruct those guys when they're in contact to pick this thing up? You can do that with constraints, but you will have, if you will want to animate later, you will have a lot of values to animate. You will have to animate the constraint on and off and the states in between, and I really almost all the time prefer automated setup. So this guy should know that it picked up something, and this guy should know it has been picked up. So what if you even want to create a more elaborate setup? So let's really sketch it before we do it. So this guy should grab, this guy should, let's say, act realistically. So it should be dynamic. So if this guy opens, this guy should fall. So this would be a little bit more elaborate setup, and I really like those challenges, and you will see how beneficial in the long run is when you really give some effort and create an automated setup. It really pays off in the long run, especially if you are animating. So let's do just that. I'll first position this in really a logical position. So let's really eyeball it and position it roughly just above this cylinder guy. We can actually rename this to cargo because it will be some sort of a cargo, and I'll drop it here all the way down in the object manager. Now I can actually select this spline and really open this grabber by this rotation value in the cloner object. Okay, that would be about it, and let's try to solve this problem. The solution for this cargo guy to move with this guy is really simple, and it would really involve a simple constraint, and that constraint would be position and also a rotation constraint. But first I will actually group this cloner guy and rename it cloner underscore group, just to be able to add an espresso tag here on the null object instead of the cloner itself. Let's check if we have zero values here. Under mode I will select object, and under coordinates we have zero values. And if I here under constraint tag, under PSR constraint, really put a cloner object here, it won't be good because the cloner is actually in the world center. You see where the axis is? You remember from volume 1, things are calculated from the axis most of the time. And also, I cannot constrain to this piece here because you can see it's not really where we want. Because if you want to say that when these guys collide with the cargo or whatever object we constrain it to, we want it to understand when the collision happened and therefore enable the constraint. I hope this is understandable. So the collision detection between this grabber guy and the cargo should trigger this constraint, and you can see that I actually cannot use either the cloner itself or this polygon mesh, but I can really use this mesh here, which is a grab mechanism. So I'll actually drop that as a target. Okay, so once enabled, this guy will maintain original distance. So I will check maintain original and activate this position and rotation. So now, since this grab mechanism is really constrained to a point on the spline, whenever I move this guy, the cargo will follow. And it's a really simple and elegant solution, and it works really well. So let's now try to solve something that's a little bit more complex, and that is that we want a collision detection to enable the constraint. So we will do what we obviously have to do. So we will find the basic property that says enable. So collision will enable this constraint. Otherwise, it will be turned off. So let's find the collision node, which is here under general collision. And this node is really simple. It takes a look of two objects and it really tells if those two objects are colliding. One thing is obvious here. We have to have cargo that will have to collide. So this is our first object, and the second one is a little bit more tricky. Let me show you what I mean. So let's actually duplicate this cargo object, and I'll drop it here just for the sake of demonstration to show you what I mean. So let's say that we want to establish if those two objects are colliding. I will create a result node here, which will give me a result of 0 or 1. 0 is false and 1 would be true. So if I move this object, you'll see that nothing happens, and the reason for it, I always get the 0 result. And the reason for it is this collision guy only works with polygon objects. So bear that in mind and convert this to polygon objects. So now you can see that once really penetrated the geometry, I get a result of 1. That means those two guys are colliding. So not colliding, colliding, which is really simple to understand. So I will get rid of this cargo 1 guy, and you will see that Espresso went a little bit insane. These yellow guys means I'm missing something, something is wrong, or something went really bad. So let's delete the reference to this object, and I'll delete this result node also. Sometimes these things can be fixed with simple rewinding, because it will tell the system to refresh. I showed you this little example because if you want to tell these guys to collide, you actually can't, because this is not a polygon object, this is actually a clone, and the real piece of geometry is here, so you cannot use even that. But there is always a solution, and we will use some tricks. And we will use a dummy object, which is often used in many setups. I will copy this guy outside of hierarchy, and I will call it dummy underscore collider. And probably some of you noticed that I have a little bit of a sore throat. I hope that won't be a problem. And we will use this dummy collider to actually tell these guys that they're colliding with the cargo and enabling the constraint. And this sounds far more complicating than it actually is, and I can actually hide this guy, and I will really show you a nice little trick that you can do with the motion graphics Espresso node. So I will select this motion objects data node, and with this node I can really extract a number of informations from the cloner. So let me grab a cloner, because I want to say to this dummy collider to be in the same position and orientation just as one of these clones. So I have to get that information from the cloner. There is one little important step that you have to do before calculating any matrices in Cinema 4D. First, I always, for the sake of safety and to minimize the possibility of errors, I always unfreeze all values. Okay, so I will instruct this data node to get the information from my cloner, which is an object also. And here under index, this index value is actually the number of the clone. There are 4 guys, that means that index value goes from 0 to 3. And I'll drop my dummy collider here and extract the local matrix. So let me show you what I had in mind. So this dummy collider, if I enable it here, this dummy collider, when I connect these 2 guys, these matrices, it will assume, you can see it here if I disable my cloner. So the matrix is, really to simplify, it's a bounding box which defines the orientation and position of the object. Okay, so now the index will control which one of the clones will be used to send the local matrix information. So let me show you. If I go here to 1, it will assume the completely different position and orientation of another clone. So 2, once again different, once again different. So I'm pretty happy with this first one, because it's really in front of us, and I will use this one. And you can also see here that if I will be using this transform value here, you can see that my dummy collider is following. So let me undo that, and I will use this dummy collider as my object, since this collision node only accepts polygon objects, and I will connect it here. And don't forget to change the mode in the collision node to object, because if you will leave bounding box here, that means that this dummy collider will collide even in this space. And also, if this bounding box is bigger, it's always bigger, and it always encompasses the whole object, then the collisions will appear before, or they will be inaccurate. So if you want 100% accuracy, use this object as a collision type. So let's check that collision. I will extract here a result node, and it will tell me if the collision is happening or not. So let's close this a little bit, and you can see that now it's colliding, now it's not colliding, and this is really neat. This is the basics for the automated setup, and it's really, really useful. So now all that we have to do is that to say that when these two guys are colliding, we will enable this. Okay? So 0 means the constraint is not enabled, and 1 means the constraint is enabled. So let's give it a shot. So that would mean that we can move our cargo freely, but as soon as we really grab that guy, we could actually move it along with our grabber. Let me undo that, and you can see that this dummy collider sometimes will stay here like this. That is a priority issue, but once animated it's all fine, and for example, if I press play here, it will jump where it should. We can solve this with moving it up in the hierarchy, but I already showed you how to deal with priority issues, and hopefully you gained enough knowledge from previous lessons. And let's really expand on this setup. Let's say that I want this object to be dynamic, as I stated before. And I can turn this object to a dynamic object really easy. I will simply add a dynamics body tag to it, and here under dynamics I will leave this dynamic to be on. This means it will fall if you press play, so something like this. And I actually want this plane to be a collider. I will add another dynamics tag here, and in this case I will say it's not dynamic, so it will not move. So now if I press play, you will see just a tiny bit of movement here, so it really sits on the floor. So now what we want to do is actually quite simple. We want to say, we'll actually hide this dummy collider so we have uniform representation of this grabber. So what we want to say is when collision happens, we want to disable the dynamic behavior, because if we leave it to a dynamic, it could potentially run into many problems. And once there are no collisions in between those guys, then the dynamics will be enabled. So that's actually quite simple. Let's drop the dynamics tag here and find a basic property, which would mean here under dynamics enabled. Okay, so currently if we turn it off like this, it will be grayed out. So this is an indication that dynamics are off. And in this case we want a complete opposite. So once the constraint and the collisions are 1, that means enabled, we have to turn off the dynamics. So we basically have to invert this value. If I connect this now, that would mean when constraint is enabled and when collision is happening, then the dynamics are enabled also. And I actually want the completely opposite. So here I will drop a bool not node, which will actually mean next. So if I connect the input here and we duplicate this result node to show you, this would mean that it will really invert the value. And you can see now I press play simply because of some refresh issues. I can enable this animation refresh. So this means that this guy here will disable something once the collision is happening. Okay, so let me show you just on the example. So if the collision is happening, then the constraint will be enabled and this guy will be disabled, and that is exactly what we want. So we will connect this here, and now our dynamics are disabled. So look carefully on the text. So if this guy goes without grabbing, then our dynamics tag is enabled. So let me show you an example, practical example of this. So if I really select the grabber here, really grab my object, so the collisions happen, I can pull it upwards. But as soon as I release this guy, then the dynamics will kick in. The dynamics only happen when things are animated. So I will actually expand my time here to something like 1000, so we have enough time. And I will right click and here and go expand to full time. So let's give it a shot once again. I will press play. I will select my spline object, maybe move this guy a little bit, so you can see that dynamics will not kick in, but as soon as I release, the dynamics will kick in. And this plane object should have stopped that, and we will enable it here. So let's give it a shot once again. This is what will happen. So we have a really nice setup. We can actually, once again, really clamp that and press play. And you can see if I move my spline here, my point on the spline, that that cargo will be held by this teeth. But as soon as I release it, this is what will happen. Okay, so that's a really nice solution. I hope you enjoyed this bonus lesson. Once again, I'm really sorry because I have a little bit of a sore throat. Hopefully that will not interfere with the way you will perceive this lesson. And I just want to mention we have a really beautiful Project One training, and it's really great if you want to learn all kinds of modeling, and it's really a 5-star training. So for the ones that haven't watched, consider getting it, and see you in the next volume, project, or bonus lesson.